All right, what are we doing today?
We're going to show the boys the solar system. It's like a modularized, fully integrated Wi-Fi connected off-grid system.
Okay, great. And who have we got here? We've got Cerbo and Paul.
And Anton.
And me. All right. Where are we going?
Step with Marty. See my messy workshop.
Oh yeah.
Which I'd cleaned up. Come on in. These, you probably know what these are, Cerbo batteries. So
How many kilowatt hours?
these are 10 kilowatt hours each.
Wow.
These three, and so they are joined, as you can see, with like a daisy chain arrangement using CAN bus, and then they connect into the Victron
Using
system.
what bus?
Using CAN bus protocol.
CAN bus, alright.
So this is the Multiplus. This is the inverter, 5,000 watts inverter. This is a regulator, maximum power point tracking regulator with 4 inputs. So it's quite big, quite a big one. I do 12 kilowatts worth of inputs. And this is a little Cerbo unit down here that is the sort of the brains that everything sort of talks back to. So
is that the interface you were talking about?
This little thing here is the interface. It's got like a control panel here. You can see like a little screen, but this is the actual interface box that takes everything, connects across to the internet, and brings all the different modules in. So it brings in the battery management system into it. It brings the Multiplus into it. It brings the maximum power point tracking in, and it also brings the remote grid-tied inverter, the Fronius, that we'll go and see in a little bit. It's got the bulk of the solar panels on it. The rest are just like isolation switches, you know, like switches for remote installate, like the different houses. This is what we're going on. So it's like a mini grid here that goes off to all the different houses on the property. That's the rock house. It's about 200 meters away. That's the roundhouse. This one goes up to the cabin, and then this one here is just for the little local cabin here, or the house we're at now.
Right.
It's a little bit of a you know,
So-
spaghetti, but
Can I ask you some silly questions?
Sure.
Which is the inverter, or is there one
this
inverter?
is the grid. This is the inverter.
Yeah.
This is the one that, and so this is the DC. This turns DC,
Right.
so AC into DC or DC into AC. But these are the lines that go directly to the that
Right,
go
so-
to the batteries.
So here's where your battery comes in.
This is the positive junction. This is the
Right,
negative junction.
And you've got to switch on that positive junction.
Yeah. So these are all coming in. The 3 batteries are coming in parallel. So
Yeah.
battery 1, battery 2, battery 3,
Yep.
and then battery 1, battery 2, battery 3, and then this is the positive and negative that goes into the inverter. Quite thick leads there. That they go into the grid inverter, all at 48 volts. And
So this is joining up all the things exactly
Yep.
together.
they're all fused off,
Yeah.
fused links as well.
So they have to, the voltages have to be the same, so they follow each other.
That's correct. So they're all 48 volts. Well, actually up to 52 volts depending on the state of charge, or 53.4 or something. But yeah, they all come into here, terminate through this bus block. The negative comes into here, terminates through this bus block, and then comes out of the bus block into the inverter. There's an isolator switch here.
Yep.
And then comes out of the inverter into 240, going up to here. Another one that goes off, there's 2 outputs, another one goes into this for the remote buildings.
Oh, I see.
And this is like little safety switches for each module. And then this is the solar in, this one here is the solar in switch.
Did you have to set this up for a lithium system?
Yep.
Yeah.
Oh well, it uses the BMS, so it draws on the BMS information. So it set itself up.
Was the BMS just a solely
The battery
lithium?
management system
Yeah.
was because it uses a Polytech Pylontech battery management system. The Multiplus understands the Pylon, is compatible with the Pylontech BMS.
So is that BMS specifically for only lithium, or could it be used on?
I think the
lead
Pylontech would be specifically for lithium.
Yeah.
It wouldn't be for lead acid. I don't think. Maybe it's possible, but like, who uses lead acid nowadays? It's very much gone the way of the blacksmith. So yeah, this is the input, the solar input. So the solar comes in from the roof, goes through the through a switch into here, and then comes out of that in. So it's quite high voltage.
So hang on, with the you've only got those two.
This is two different. I've got two different input methods. This is a DC to DC. This is a DC to DC charge. So it comes in DC, quite high voltage, probably 140 volts, coming through the switches and into 140 volts. It then gets.
Is the red positive and negative on both?
That's correct. Yes.
Right,
So there's two different units. This is a 4-input system. So this maximum power point tracker allows 4 different
strings.
400 volt, maximum 450 volt inputs, up to 200 amps. So only 2 of them are being utilised at the moment. It's got a lot more capacity that I'm not using, but I just got a bigger one because I could at the time, and I'm probably going to move this to a dedicated.
They're the other 4 that you could connect in.
Yeah, and I'm going to move this whole system to a dedicated battery system room at some stage in case the batteries ever catch fire and won't burn the house down.
And so when you set up your panels, did you set it up to how close to is this the voltage of the panels, and this is the current of the
yeah, it's maximum voltage input is 450, 450 volts, and the maximum current is 200 amps.
Okay.
So it's a bit hard to see.
So did you set this up to what sort of voltage did you actually set it up to?
I could look on the I could look on. Hang on, here we go. 270 volts are coming in.
Right.
So I didn't put it out to its maximum, but 270 volts, 120 volts coming through on number 2. So that's 370 on that one, there's 120 on that one. There's different voltages coming through on each one, but they can go up to 450.
And did you set up the panels as well?
Yep.
Geez, you're a brave man handling all that high voltage.
Oh, well, you just, you've got a switch and you just, just connect it with
Put blankets over the panels or something?
No, you just, just have the switch turned off, and if the switch is turned off, then it's only when you flick the switch on that
yeah, but when you're actually up on the roof, actually connecting the panels, you've got to be pretty careful there.
Well, it depends. If it's an open circuit, if you don't have your finger on one thing and you're doing anything on the other, I mean, if you're just touching, if you're just touching one of the leads, like a positive or a negative, and the other one's not grounded or you're not touching, not in any way connected to it, then
and
it's
the roof isn't touching the roof or anything like that. Yeah.
Yep, it's fine. But so this is one of the feed-ins. So this is a DC to DC feed-in. This is a maximum power point tracker. So it comes in DC from the solar panels into the box and goes directly to the batteries in DC. The other one I've got is what's called an AC coupled device. So it goes DC into the Fronius grid inverter. We'll go and have a look at the moment, and then it converts that into 240 volts, and then it feeds back 240 volts back through all these circuits, or back through the 240 volts grid that actually can supply. Like at night time, it's going that direction, but when the sun's shining and it can go up to 5,000 watts, it'll actually flow back the other direction and come into the Multiplus, and then turn back from AC. It'll turn it back into DC and charge the batteries up.
So this is a bidirectional.
Bidirectional. That's exactly what it is. There's 2 different charging systems here. One's a DC to DC, and one's an AC to DC charging. So it's got 2
what
different
did you pay
methods.
for this?
Maybe about $3,000 or something.
Right. And
that was a bit more expensive, maybe 4.5 or something like that.
Wow.
But I haven't used. The plan was to have at some stage to put this over in a dedicated housing just for all the power and stuff, and then actually have like a bigger housey shed sort of thing. So I sort of future-proofed it. At the moment, I'm using a small capacity of a fraction of what it's capable of, and that's when I realised that actually I needed most of the power needed to be on the bigger roof that's already existing over there, and so I looked into it and realised that if I bought a grid inverter and I could do this AC coupling, which is coming back across the AC system rather than having to run really big thick DC wires from there all the way back here. And that's the benefit of it.
Cool.
Yeah.
Very nice. And did you kind of have any sort of video or book or something to follow? Like
Come on, darling, come in.
Or how did you actually get the knowledge of?
Oh, doing this? Well, I did at uni. I did computing and electronics
Right.
for a number of years. So doing AC and DC stuff is pretty simple when you've done linear circuit analysis. I don't know. It's and also I don't know. You just look like all the configuration.
Read all the manuals and stuff.
Well, yeah, manuals and configuration of the Fronius stuff. Yeah, you just watch videos and YouTube is great. And the manual, the SunPal batteries. I had to read the manuals and work out what the dip switches were.
So did the Fronius sort of stand out for any particular reason?
Yeah, because a lot of people have been using Fronius in conjunction with the Victron. They sort of they sort of tout, I don't think
other
Victron
people have been doing this sort of setup.
Yeah, I don't think Victron do a grid inverter. I don't know if they do. So they sort of partnered with Fronius. I think they're all German or something. And
I think they do, but it's not listed in Australia.
oh right, okay. Yeah, so I picked up a cheap. It was quite cool actually. I found one on Marketplace for $400 and up in Brisbane. And I said, I don't suppose the guy...
The Fronius one.
The Fronius one I got second hand from
Wow.
just someone, like pulled off, like it's a 5K system. And I said, I don't suppose you're coming anywhere near Byron in the next few days as a joke. He goes, I'm coming down to Brunswick Heads tomorrow to go camping for the weekend. So he bought it down. We went to the petrol station and gave me his $400 and got my grid inverter.
Meant to be.
It was meant to be.
Okay, well that's good. And
I'll show you the Fronius now anyway.
Yeah,
That's
and
my
what's
internet. This is
that?
my internet Wi-Fi. So the internet comes in, and then this is connected to the.
so that's when you were doing it.
Through my-
showing it.
So
at the
this
market.
the little servo box here, the control unit, brings everything in. It also hooks up to the Wi-Fi, so you can basically
Remote monitor.
monitor everything. And
How much did that cost?
I think that was about $800 or something, but it was money well spent. I've just spent, I can do everything right. You can even do remote generator starts and all that sort of stuff with it. You can do, and also there's all these devices have all got relays on it, so you can actually remotely, if you had tanks, you can remotely start pumps. You can do all sorts of things remotely through the actual interface.
That's good.
And if you want to take a next step, you can actually get like a little Raspberry Pi box, and you can load up open source home automation software, and you can bring all your home automation sort of things connecting in to this little box. And
So if you're travelling around Australia or something and you can detect that there's thieves going into your house, you can electrocute
well,
them?
that's not, yeah. Well, you wouldn't want to do that, but you might. What you could do is you could say, look, I've got Internet of Things like connected dehumidifiers, so they can remotely set up a program that's saying if the humidity levels get above 80% and there's 60% battery and there's forecast good weather coming for the next day, crank the things and just keep them running even overnight, or until there's certain thresholds or things. So you can do all that sort of stuff. You can start to automate your house and stop the mold growing and or
Fantastic.
monitor all sorts of things and monitor and respond in any particular way using home automation software. And that the Victron interfaces into those, and it's going to be an interesting future. And you can also bring AI into it to actually manage it all for you. Connect the ChatGPT in and get it to make decisions on your behalf, bring temperatures up, monitor everything.
Have you actually tried that? Or?
No, not yet, but I'm thinking about getting a Raspberry Pi at some stage. It's a bit of a deep dive, how much time do you have,
Yeah.
How much time do you have?
Those batteries, they're in parallel, are they?
They are in parallel, that's right, and they're daisy chained, and they've set up, that's a master, and it's slave 1 and slave 2, and then there's an output as well that goes to the Victron, that basically, so I can see the, I can either see the voltage state of charge, either determined by the Multiplus, or I can actually view it as far as the batteries are concerned, so I can monitor the battery module.
So they're all just going to be the same voltage.
Not necessarily. Like I've got a problem with one little cell that when it gets close to 100%, it actually, one cell's just going a little bit too high and it's throwing errors up. But you can have a look at, you can look at the monitors on here as well. And where is it? Enter menu, BMS status. cell voltage. You can check all the.
Does this do any balancing?
It probably can, but you can see all the individual cell voltages here. 3 point, so they're all slightly different. There's some of the, well, actually pretty consistent today. 3.59. They're all pretty much the same. Sometimes you'll get like, oh, there you go, that one up top there, 3.50 or 60. That one's 0.001 different, or just actually.
How long have you had these for?
Close to a year now, and they're still at 100% health apparently, as far as the BMS is concerned. Yeah. Okay, I'll show you the Victron if you want. Show you how that comes back. Sorry, the Fronius. Okay, the Fronius. That could be one of the pointers for the.
So each BMS on each battery has got this readout. Yeah. And how many cells in each battery?
So this is the Fronius, just here. How many cells in each battery? I think there's 15 cells.
Oh yeah.
So this is the Fronius, this is the grid inverter.
Mm-hmm.
So that is currently only producing 490 watts. But they come in from the roof in 2 different strings, or actually that's just one coming in at the moment. And it goes into the Fronius and then it comes back onto the 240 volts, back onto the grid.
Right.
And
Simple as that.
Simple as that. And then if the power's, if this is producing like 3,000 watts, and somewhere in the system, because it's an AC to DC, if we're using like, the washing machine on, the dishwasher, heap of lights running, whatever, it'll draw directly from the AC rather than even trying to convert it into DC. So it'll use the AC power first before it actually tries to stick it back into the batteries. Right. So you get efficiencies in that regard as well.
What are these?
They're just the extra inputs, so I haven't connected up yet. This has capacity to actually take 2 separate.
They're panel connections.
Panel connections, that's right. So these are coming in from the roof, and that one there is a spare one, which, because there's still another bank I haven't even bothered connecting in yet, which of about 5 panels that I should still do at some stage. But yeah, anyway, and you can, this menu, you can go to the menu. It's too small, but you're not going to see too much anyway.
It's a good buy for 400.
Well, it was practically brand new. He had it in his garage. It had been left in his garage, and so it was like not even in the sun or the weather. It was like a brand new unit for what it was. Yeah, and that's the benefit of these things, that you can pick up these things really cheaply off marketplace that work, and it's cheaper than buying a big maximum power point tracker. It's actually a much more effective and cheaper way of doing it.
You've also, go on.
What are you? Which PowerPoint tracks are you talking about?
So there's a maximum power point tracker, the DC to DC regulator, and this is an AC to DC.
And that's got a PowerPoint tracker as well?
No, well, this actually it does have maximum power point tracking built into it as well. But when I say maximum power point tracker, I meant the DC, the jobby down there. So this is actually a cheaper way. It's cheaper to buy, like if you wanted to get a 5,000 watt maximum power point tracking regulator in a Victron brand.
Yeah, they're about $800 or something.
Maybe a bit more for a 5,000 watt.
Yeah.
Okay. Well, you might be able to find one of these, which is a 5,000 watt one, for $300 because people have ripped them off their house, and there's not much market for second-hand grid inverters. And that will, if you've got a Multiplus, it will feed straight in.
So what's your business at the moment?
My business at the moment is IT related, doing some AI stuff.
For various people?
We're writing a program at the moment, software software as a service for councils.
Right.
Yeah.
Oh, so it's a product that you've got to sell?
Yes. Yeah, we're just about to launch it.
With other people?
I'm launching it, yeah, soon. We're still in the final development stage, but whether it actually...
I'm just curious, because you're spending a lot of money, I'm just wondering...
okay. Well, the main purpose was, we got here, there was no power, and there was, on this property... Can
we get under the shelter over there?
Sure, 100%.
Yeah. Yes, sir. So, yeah, how do you manage it financially?
Well, we've been locked out of our property for a long time, for 6 years, and then this lovely man bought this property, and he lives down in Sydney, and he's not very technically competent, but we were very grateful that he let us into our property and we rented this little shack off him as well.
So
and,
you share a bit of the power.
So I, as a show of my gratitude, hooked up our place, this place,
Right.
and another house that he's renting out,
Right.
and I've set up a big mini grid, I power the whole property as a thank you so much kind of thing.
Great.
It's it would have been a big cost for someone to have done
Right. I see.
it all, with the engineer and do it all officially.
Yeah. Great. Fantastic. Well done.
Thank you.
I missed out on the part when you the power. Has this got panels on it? This roof?
This roof does, yes.
And your place has got panels.
That's correct.
So you've got a hell of a, you were saying 140 volts you've got coming in.
At my place, and there's probably more voltage, probably about 300 volts coming in to the inverter at this place.
So it comes off the roof and it goes into the power goes directly into the Fronius, does it?
That's right.
And so therefore it's converting in time, in real time, the voltage coming from the panels
Yep.
in real time into AC.
That's right. Because there's already a grid with the Multiplus, it's already established a frequency, a 50 hertz frequency on the grid. So it syncs in with that's how so grid inverters, they sync in with the local frequency, and then it can supply power back to the Multiplus, which can be quite some distance over AC, high voltage AC, whereas if you try to take it back at 48 volts you'd need a very thick DC cable to get all the way back. But in this case you can use the existing AC infrastructure. And the way it communicates remotely is by shifting the frequency. So standard frequency is 50 hertz, but I think it's 54, I think it goes up to. It will change it to 54 hertz when the batteries are fully charged. It'll raise the frequency of the signal to let all the remote grid inverters know that they should stop providing power, so the batteries don't get overcharged.
What other grid inverters have you got?
In this case, I only have the one, but in theory, you could have. What a lot of people do is they can have like what's called a micro grid inverter, so that every single 400 watt panel or whatever you have has its own little grid inverter, and you can just stick them all over the place, distribute them wherever there's like a roof with space. You can just put a little grid inverter with a panel, a giant panel or two panels, and stick them all over the place, and they'll, as long as it doesn't exceed the
Current level.
the power level, 5,000 watts of the Multiplus, then you're good. They have what's called a factor 1 rating, so you can't exceed 5,000 watts total in your remote grid inverters. But that's just this particular brand. I know that the SAE, I think it's called, brand allows you don't actually have that limit. It's only the Victron that has that factor 1 limit for some reason.
SME?
SME or SAE? Yeah, it could be SME. I'm not sure. There's other brands that do have, don't have that limit, like the Victron.
So that Fronius is actually an MPPT and an inverter built into one.
Correct. Yeah.
Wow.
It goes back AC across to the main device, across to the Multiplus. AC coupling, it's called, as opposed to DC coupling, which is what the other, like standard regulators are, like a standard DC regulator.
So people in places around Mullum or somewhere, their grid inverters are also MPPT and inverter built in one.
Yes.
Okay.
How much was the battery? I think I've asked you before, but
I think I paid $4,000 each for them, or maybe $4,400. There was like I had to pay some import duty at the end, but it was about $4,000 for a 10,000 watt inverter. So battery.
from what organisation?
Oh, it was just a friend who's an electrician bought them in. He bought them in primarily for his father, but then, as I said, he realised that they couldn't use them because their insurance wouldn't cover them,
Right.
because they weren't CTIC approved
Oh,
or
yeah.
something like that, or weren't official Energy Council approved or something like that.
So they'd probably end up paying $10,000 for the batteries.
Oh no, he gave them to me what he bought them for.
No, but I mean his father or
Oh yes,
might
he would
have
have
paid a big.
probably had to ended up going out and buying Tesla Powerwalls or something. Right, so I've got even though I've got a grid-tied inverter here, and I don't have any mains power because I'm off grid, the way it works is that the grid inverter sees power generated by the inverter. Now what happens when the batteries get to 100% is that it does what's called frequency shifting. So the Multiplus, is that beeping for some reason?
Yeah.
Okay.
All right. Meltdown in 2 minutes.
Okay, so the Multiplus sees that the battery state of charge is reaching 100%, and as it gets close to 100%, it actually increases the frequency from 50 hertz up to 52 or 54 hertz, I think it is. And
Which you programmed.
you program into it. You program both sides, the Fronius and the Multiplus, and then what happens is when the state of charge gets to 100%, it brings it all the way up to 54 or 52 hertz, and any remote grid inverter senses that and powers down. Basically, stops its current output.
Yeah, great.
What were you saying about voltage? If the voltage cuts out, the whole thing has to shut down.
The grid or the 240 volt feed is not available, then it's got to turn off the grid tie inverter
It does anti-aliasing, but yeah, it turns
to prevent
if the Multiplus
the lines from
being live.
yeah,
That's right.
being
If you
live.
switched off the Multiplus immediately the grid inverter would turn off.
Satisfied?
I got to think about that one.
All right.
You'll have to edit that.
It's no, there's been no damage. No, this is a momentary voltage spike that pops it up over the set voltage limit, and so it throws an error up. But it's not like a surge. That's right. That's the word I should have used. A little surge, but only for a split second, and only enough to throw up an error message. It doesn't actually do much damage, or any damage that I know of. You just got to be careful when you're at 100% state of charge and you've got a big load on, and all of a sudden that giant load just drops because it takes a bit of a time for the system to respond. That's what we're talking about.
Mr. Pody, you got any further questions?
I wish I'd woken up not so early this morning. 2 o'clock wasn't good.
That's all right. You can always fire me anything back you need. But, you can always come again and visit. Or
Yeah, no, I get the picture. It's good. It's great work.
Thank you.
How do those neighbours that you're also powering, how do they tire in? Like there's beyond this place, there's somewhere else.
Yeah, another one 200 metres away.
Yeah.
So
How are they? Where are they actually plugging into?
I've just made a massive great extension lead, but really fat copper cable. It's like 10 mil cable or something like that. 10 mil squared cable or 14. Can't remember what it was. Basically, you do a voltage drop calculation. There's online voltage drop calculators, and you basically put in the length, the cross-sectional area of the wire, and it'll tell you. I think it's 5% voltage drop is the allowed amount.
You're talking about AC voltage.
Yeah, AC. That's right.
So therefore, you've got more efficiency here.
Well, it's more about calculating a maximum voltage drop. So, you know, you're allowed up to 5% voltage drop, I believe, by the standards. And so basically you put that in and yeah, it's the cross-sectional area of the wire, the length, these two factors, and the resistivity of the metal as well, but we don't, you know, that's obviously set because it's copper. And then basically you can work out what the voltage drop is, and you say if that's acceptable, and that's how you gauge your wire for the length.
Right.
So I had 200 metre, two 100 metre cables, and I think for that distance it came in for a certain maximum power. So you've got to actually take in the amount of power you want to have over there. So I designed it for 5,000 watts, the maximum of the inverter, and put in protection equipment so it wouldn't peak over 5,000. And so over that distance with that wire, with a 5% drop, it was determined that I needed to use 16mm squared cable.
So what happens if they actually draw too much power for this AC Fronius, you know? Can it draw from the DC to DC somehow?
Yeah, so it can draw from directly from the AC grid inverter.
Yeah.
So it doesn't even go into the batteries, it just goes from the roof here through the grid inverter straight into the appliance,
Yeah.
wherever it is, here, there, or wherever. And if that's not enough, it then starts drawing as well extra. It turns back DC power from the batteries back into AC to supplement the grid inverter on the roof.
And so that's your Fronius drawing from the DC to DC.
No, it's the Multiplus drawing from the DC. So the Multiplus is what does the DC to AC conversion. In both, it's bidirectional, so it'll either draw DC power from the batteries to turn into AC, or take AC to put it back into the DC to power the batteries.
Okay, so the Fronius grid tie is connected to the Multiplus?
It's connected to the Multiplus through the grid. Like you could have a number of different grid inverters all around, anywhere on the mini grid, on the grid here, like whatever house it is. You might have a roof here or a roof over there. You could put panels on the roof. You could have a grid inverter that was compatible with frequency shifting, and then it would feed back from those panels all the way back through the existing AC infrastructure, the AC cables, back to the Multiplus, and turn it back into DC to charge the batteries.
There is mud.
No, it's okay. I'll look it up.
Watch the video.
We'll watch the video. There you are. What did you think of that, folks?
Renewable solar revolution. Batteries are becoming extremely cheap, and it's going to change the world.
What are we doing now?
So now I'm just showing Sapoti the Victron interface from the Cerbo, and all the different analysis and AC power coming in, and all the different sort of components of the system. So basically you can see at the moment we've got 81% state of charge. There's 470 watts going into the batteries. This is the Multiplus here, so at the moment it's inverting because we're, well, which way is it going? Let's have a look. So we've got total solar, 2000 watts. The the Fronius over here is producing 1300 watts of power from the AC coupling. Then the DC regulator is producing 840 watts, and there's an AC load of 430 watts. So what's happening is that basically this inverter is feeding power. This AC load of 470 watts is coming directly from the photovoltaic inverter. It's not even going into the DC, but what's left is about 900 watts that is then being fed through the inverter, being converted to DC, and combining with the DC DC charging, and creating a total of 785 watts going into the batteries. So does that kind of make sense, Sapoti?
Sort of, although I don't understand why is this over here? Shouldn't that be over there?
Well, it's just this is the DC side of things.
Right.
So this is just below here is the DC side, and this is the AC side. So it's saying there's 470 loads of 470 watts of load, and then the AC side as well. There's the AC grid-tied inverter is doing 1300 watts, and so basically most of it, it's basically the grid inverter is supplying all of the current AC load. So it's not even going into the batteries; it's just going to supply the load directly. And then there's still about 900 watts of excess power that's then going AC into the inverter. That's converting it into DC. And charging the batteries, combined with the maximum power point tracking regulator. So it's a total of 1700 watts now.
Right. So there's some panels associated with
there's panel there's panels on the RS400, the DC regulator.
Right.
There's panels on that. There's panels on this Fronius inverter. So that's on the AC side. That's on the DC side. So basically it's coming through the inverter. AC to DC, in this case it's flowing back into the batteries, or flowing back through the inverter, rather than flowing from the batteries out of the inverter. And the 800 watt load is being supplied directly from the photovoltaic inverter. And the excess is going into the batteries. Does that make sense?
Pretty much, I
And you
think.
can go to the console. It will just show the console, which is pretty much the same where you do all the configuration from. And that gives you a bit more even in-depth view.
What is this the in-depth view or the
This
other
is
one?
more of an in-depth view because you can go into the settings for each one. You can look at the device list, so you can see these are the devices connected to the controller, the Cerbo controller. I've got the Fronius coming in. I've got the maximum power point tracking device. I've got the Multiplus inverter, and I've got the actual pylon tech battery monitor. So the BMS system. So it's got all these 4 things being inputted into it. And so if you want to break down, you can look at the maximum power point tracker. You can see that of the 4 inputs I've got here, I've got 1600 watts coming in from solar input 1, 750. I've got 500 watts coming into the through solar input 1, 251 watts coming in through the second one, and the third and fourth aren't connected. But you can see the voltage. Paul, you asked about the voltage before. There's 284 watts
Yeah.
and through the first one, 130 volts through the second one. And I think we can probably go back and look at the Fronius, and we can see as well there's an AC. It's got 2 AC phases in, and it's currently producing 1,000 watts. Can we see the breakdown of the voltage? I'm not sure if we can. Maybe we can. AC total. Yes, 1,000 watts, but I can't see what the actual input voltage is, unfortunately. The output voltage is 235 volts. We can look at the Multiplus inverter. We can see the current state of charge. We can see the current frequency as well. Just based on the where's the frequency advanced maybe? No, not there. Anyway, this is the configuration side for it all. I wonder where the frequency is. Oh, there it is, 50.1, 49, 50.1 hertz. So as the battery state of charge gets to 100%, this frequency, the Multiplus will increase its frequency. It will shift it up, and then the Fronius is set to detect this change in frequency and will throttle itself based on the frequency, the input frequency, or the mains frequency. In this case, generated by the Multiplus.
So it can throttle rather than just turn itself off.
Well, when it gets to a state of, it'll start throttling it at like 53 hertz, and then by the time it gets to 54, it'll completely shut it off. I can't show you that setting because it's done with a control cable directly connected to the.
I'm a bit confused here. So why is it cutting off because the battery's full, or what's the reason for it cutting off?
That's right. So once the state of charge gets to close to 100%, or once it even gets to 100%, it'll raise the way it communicates remotely with the grid-tied inverters to tell them that stop sending power is by shifting the frequency, which is normally 50 hertz for any standard AC. It's only 50 hertz, but it brings it up subtly to communicate with the remote grid-tied inverters that support frequency shifting, to know that it's time to stop its feed.
Okay.